Hi everyone, I hope you can hear me. I'm going to be getting started in just a moment. I just want to make sure that all my settings are set up properly. Hi everyone, I hope you can hear. Okay, I promise I haven't looked at these before, and I'm going to try not to look at them now. Okay, I'm going to add a blank document so that I can do all my scratch work. And I'm going to make it a ton of pages because who knows how many pages I'll actually need. Okay, okay, and then I'll zoom in a bit, or a lot. And let me just make sure that everything's working properly. Okay, that looks good. Okay, I can make lines. Okay, so I do have some tools that they wouldn't allow on the actual test, but I'm not going to be using Desmos or any crazy graphing tools, obviously. Okay, so I guess, well, it's 2:01 now, so let's get started, and I'll finish at 3:16, and we'll see how I do. Okay, here we go. Okay, what is the value of, okay, well, this is just a bunch of addition. And each digit appears once in each spot. So, and 1 plus 2 plus 3 plus 4 is 10. So it's going to be 10. I guess I'll write my answers in the other document. So for problem 1, the answer should be 10 times 1111, which is 11110. Okay, what answer choice is that? That is E. Okay, that wasn't so bad. I can handle that. Okay, number 2. The area of this, maybe I'll circle it here too. Okay, the area of this shaded figure. Let's see. Okay, so the big triangle has base 4 and height 5, so that's area 10. And then I subtract 5, wait, base 4, height 5, yeah, that's 10, minus 1 times 4, or half 2 times 4. So it should be 6. Or you could split it in half like this, and then you have 2 triangles with base 3 and height 2, so it should be 6. Okay, so that, these starter problems aren't so bad. Wait, what option was that? That was B. Okay. If they're all this easy, then this should be a breeze. Okay. Pretty soon I'm going to actually start having to, I might have to copy and paste some of these diagrams and things, the problem statements over. Okay. At noon, Minneapolis is N degrees warmer than St. Louis. At 4, the temperature in Minneapolis has fallen by 5. On St. Louis, it's risen by 3. Okay, so the gap has shrunk by 5 plus 3, which is 8 degrees. Yeah, because Minneapolis was warmer. So now they differ by 2 degrees. Oh, okay, so depending on which is warmer. Okay, so they could have, so now they differ by 8 degrees, or the change was 8 degrees and now they differ by 2. So they could have differed by 6 or 10 degrees, so the product should be 60. Oops. Let me actually circle that. Okay. Still no need to actually do any work. So that's a good sign. Okay. And feel free to, if I get really stuck or if you have comments on a certain problem, feel free to say something, but I'm going to try not to use any hints unless I get really stuck. Okay. 8 to the 2022 divided by 4, so that's 2 to the 6066. So divide by 4, that's 2 to the 6064. Okay, so that's 4 to the 3032. Okay, so that's E. Okay, this is going better than I thought it would. Okay, okay. And at the end, I guess I'll go through these, my answers, and see which ones I missed. And if I missed any, I might try to go back and figure out what went wrong. Hello, everybody. I guess I'll type in hi, just so that you know that I'm talking to you. Okay, so first 4, not so bad. Call a fraction special if a and b are positive integers whose sum is 15. How many distinct integers can be written as a sum of 2 not necessarily different special fractions? Oh. Okay, so I'm going to write the numerator as 15 minus b. So 15 minus 15, well, maybe 15 minus x over x plus 15 minus y over... Oh, what happened to the... Come on. It's not detecting that for some reason. That's weird. Okay, I'm not sure what happened there. 15 minus y over y. Okay, so that's 15... Okay, so I'm gonna need more space for this, definitely. So I'll get rid of that. I think it's a little laggy just because I'm streaming. Okay, so 15 minus x over x plus 15 minus y over y. So that's 15 times 1 over x plus 1 over y minus 2. Okay, and the question, maybe I should start copying and pasting the questions as well, because I can't keep track of all this in my head. Okay, how many distinct integers can be written in this form? Okay, so I need 15... Well, I can write that as 15 times x plus y over xy. Well, minus 2. So it's 15x plus y over xy minus 2. Okay, so... Okay, so it'll definitely work if 15 is a factor of x, y. Oh, okay, one issue is that if x and y are too big, then this 1 over x plus 1 over y is going to be really small. So, maybe I'm missing a quick shortcut here, but, let's see. Well, so x is a factor of... maybe I should write down their GCD. I don't know. X is... So say GCD xy is d. So then x is dA and y is dB, where a and b are relatively prime. So then I get 15 times dA plus b over d squared AB. Oops, there was a bit of lag there. I'm going to forget about the minus 2 for now. Did it want positive integers or just integers? Distinct integers. Well, okay, x and y need to be positive, so... Oh, but that could be negative. when I subtract it from... Oh wait, no, x and 15 minus x are positive. Okay, so the fractions are positive. Okay, so the d's cancel, and I get, I get 15 a plus b over d a b. And now a and b are relatively prime. So if a had a common factor with a and b, then that would contradict them being relatively prime. And similarly for b. So AB is relatively prime to a plus b. So AB is a factor of 15. Okay, so that doesn't leave too many choices. Can D divide the sum? I think so. But that's not too interesting. Do I really have to go through every possibility here? Well, and a plus b and a and b have to be relatively prime. So I could have... Okay, I might have to skip to another problem because I'm probably doing something... I might be wasting time on this. Okay, I think that's all the possibilities. 1, 1, 3, 1, 5, 1, 5, 3. Oh, the 15, 1. Yeah. Okay. And then... okay, so then for each of those cases I get something with a D in it. So I get... The first case gives me 30 over D. This one gives me a plus b is 4, so that's 60 over 3d, so that's 20 over d. Well, again, minus 2, but I'm not going to worry about that because that doesn't matter for the distinctness. Okay, 5 plus 1 is 6, so that's 90 over 5d, so that's 18 over d. 8 times 15 over 15d, so that's 8 over d. And then that's 15 times 16 over 15, so that's 16 over d. Okay, so now I just need to count the number of integers that are divisors of one of these things, because d can be anything, any positive integer. So, okay, divisors of 8, 16, 18, 20, or 30. So I guess I'll take the LCM of those, and... Well, no, that won't work. I guess I really have to do... I do have to list them out. Oh, gosh. Okay. This probably isn't the fastest way. 1, 2, 3, 5, 6, 10, 15, 30. And then this is 1, 2, 4, 5, 10, 20. And then this is 1, 2, 3. Ugh. Well, no, why don't I just check... That's silly. I'll just check the integers from 1 up to 30, I guess, and see which ones do and which ones don't divide it. Okay, so get rid of all that junk. Okay, so 1 definitely works. 2, 3, 4 divides 8. 5 works. 6 works. 7 won't work. 8, 9, 10, 11 doesn't work. 12... No, that won't work. 13, 14, no, 15, 16, no. Oh, yeah, 16 is right there. So 18, and then 20, and 30. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. I hope that's an option. Is it, please? Shoot! Okay, I'm gonna come back to that. Maybe I'm missing something. Oh, I want their reciprocals to be distinct. Dang it. Okay, I'm gonna skip that for now because I'm spending too much time on that. Okay. Problem 6. Okay. Okay, the greatest prime number that's a divisor of that thing is 2. Because, okay, what's the sum of the digits? The greatest prime divisor, or the greatest prime, yeah, greatest prime divisor of 16,383. So that's 2 to the 14th minus 1. Okay. That's not too bad, actually. Just factor that over and over and over again. This seems... okay. 2 to the 7th plus 1. Is it really this simple? This is the AMC 12B. Okay. So it's 129 times 127. 127 is prime and 129 isn't. So 1 plus 2 plus 7 is 9. Or no, it's not. It's 10. And then that's my answer. Huh. Okay. I guess yeah. Okay. So that would be option C. Well, I guess I'll just circle them on this page so that it's easiest to see there. Okay, so I circled them so far. Yeah. Okay. Okay. What is it? Well, okay, so this is x squared. I think I know right away what to do with this one. It's x squared plus y squared plus z squared minus xy minus yz minus zx equals 1. And I can double this and then I can write it as a sum of squares. So if I double it, I get 2 of each square and 2 of each cross term. So it's x minus y squared plus y minus z squared. Sorry, the z's look like 2's and the 2's look like z's. Okay, plus z minus x squared equals 2. Okay, so 2 of them have to be 1 and 2 of them have to be, well, yeah. So 2 of these factors have to be 1 and 1 of them has to be 0. So 2 are equal and 2 differ by plus or minus 1. So if x equals y minus 1, then this first term will be minus 1 and y z minus 1. No, because then they won't be distinct. Should be x equals z and y minus 1 is x. Okay, so it should be D. Okay, because otherwise they won't be, 2 of them won't be equal. Well, okay, they will be in A, but x greater than y isn't a sufficient condition. Okay, problem 8. Okay, I do feel bad for skipping 5, but oh well, that's the way it goes. Okay, problem 8. Oh boy, okay, I'm gonna start having to draw diagrams here. The product of the lengths of the two congruent sides of an isosceles triangle is equal to the product of the base of... Yeah, I can't do this. Okay, in my head. So I'm going to copy and paste this for sure. Okay, so let me copy and paste this. Okay, this is a tool I wouldn't have if I weren't doing this on a computer. But okay, will this work? If not, I'm gonna have to think of something else. Okay, I'm a little new to this technology, so we'll see if this works. No, I don't think that did anything. Oh, I know what I can do. Okay, never mind. I got this. Okay, I'm probably gonna be wasting some time just figuring out how to do the copying and pasting, but oh well. Okay, so I took a screenshot. Go away. Go away. I don't need the notification anymore. Okay, where is it? Okay. Yeah, I gotta shrink this a bit. Oh, shoot. Wait, I got this. Okay, I need to zoom this out because this is getting... Okay, there we go. Okay, the product of the lengths of... okay, I'm gonna have to draw a diagram for sure. Okay, the two congruent sides. Okay, so let me draw this. Of an obtuse isosceles triangle. Okay, first out, get that part right. Okay. Okay. Is equal to the product. Okay, I'll call this A. And this A. Product of the base, and this B. Okay, so, and then this will be H, I guess. Okay, so the product of the lengths, so A squared equals the product of the base 2BH. Okay, what is the measure in degrees of the vertex angle of this triangle? Okay. Okay, so H, I use the Pythagorean theorem, so it's square root A squared minus B squared over 4. Okay, so if I square this, yeah, I'll get a to the 4th equals 4b squared times a squared minus b squared over 4. So that'll give me the ratio between a and b, I guess. It'll give me a quartic, but, okay, so I'll get a to the 4th equals 4 a squared b squared minus b to the 4th. Okay, so now, I guess I'll move everything over to one side, and, so I get a to the 4th minus 4a squared b squared plus b to the 4th is 0, and then I'll divide through by a to the 4th, and I'll get a quadratic in a squared over b squared. So I'll get a squared over b squared squared minus 4 a squared over b squared plus 1 equals 0. Okay, so then a squared over b squared equals 2 plus or minus root 3, and b is the longer side, so that's going to be the plus sign, or sorry, the minus sign, because, yeah, b over a is 2 plus root 3. Okay, and then I want this angle here, the obtuse angle, so that would be, okay, so sine, let me call it theta, so sine theta is b over 2a. Oh, what? The 2 disappeared for a second. Yeah, okay. Okay, so sine theta... okay, yeah. Sine theta is 2 plus... Wait a second. That can't be. Wait. B over A. Square root. The square root. Okay, and I think that's, oh gosh. That's like I think that's a 75-degree angle. Yeah, because root 2 plus root 3, I think that's like root 6 plus root 2 over 2, something like that. Okay, so this angle should be 150 degrees. Yeah, it's got to be twice a nice angle. Okay, so it's got to be D 150. Okay, I'm about 20 minutes in. That's not so bad. Okay. I don't think I've made any stupid mistakes so far. Well, okay. I did skip over problem 5, which I might have to come back to. Okay, another geometry. ABC is equilateral with side length 6. O is the center of the inscribed circle. What is the area of the circle? Okay, I think I can do this one once I draw a picture. So let me do that. Copy and paste. Move this down. 1 second. Move down, move down, move down, move down. Okay. And then move down, move down. Okay. ABC is equilateral with side length 6, so let me draw that. Okay, and then I've got the center of the inscribed circle. Okay, that's just a centroid. Or whatever. It's basically every special point in the triangle when it's equilateral. So that's O, and then I want AOC, so that'll be this, the area of this circle. Ah, okay, I actually did a problem just like this recently. So, okay, so let me zoom in a bit. Okay, so this angle here is 120. So this arc here all around is 240. It's double the inscribed angle. So then this arc here is also 120. Okay, so that angle is 120 with the center. Okay, and I want the area, so I need the radius, but the radius is just the same as, I mean, these two triangles are both isosceles, so they're congruent, and then the radius is the same as this length here, and I think the side length was 6, right? Side length 6, yeah. Okay, so this side length is, this side length is 6, and then I need just the length of this thing. Okay, so this is 3, and then I just multiply by 2 over root 3. I don't want to screw this up. 2 root 3, yeah. It's easy to mess up these ratios. 2 root 3. Yeah. Okay. So then the radius is 2 root 3. So the square of the radius is 12, and then the area is 12 pi. Okay. Please let that be an answer. Okay. Yes, it is. Okay. So it's b 12 pi. Oh, go away, please. Okay. b 12 pi. Okay. I'm doing better than I thought I would. Okay, what is the sum of all... okay, this one I don't like so much. Okay, we want an isosceles... Oh, I guess this shouldn't be so bad if I just graph it. So we want an isosceles triangle, and I've got 3 points on the unit circle. Okay, time to copy and paste again. Okay. Okay, I'm just going to go to a new page for each problem, because that'll make things easier to deal with. Okay. Where'd it go? Okay. Oops. Okay, so let me draw this triangle. Or no, well, I'll draw the first few points. I need to zoom out some more. Okay. Okay, that's probably the best circle I've drawn in days. Okay, so I've got the unit circle, and then I've got 40 degrees here, and that's more like 30, but whatever. And then I've got 60 degrees here. and then I want to know when this is isosceles. Okay, so one option would be to just go directly across. So I could have that point. So that's if this side here is the base. But I could also have it be one of the other sides. So I could have two congruent sides like that, or two congruent sides like that. Okay, so this arc length is 20, or the measure. So if I have two congruent sides, that would be another 20, and that would be another 20. Okay, so this point here is 40 minus 20, so that's 20. And this point here is 80. And if it's diametrically opposite, I've got 50 right in the middle here, and then I add 180, so I get 230. Okay, so that should be a 2. Okay, so 20 plus 80, that's 330. Okay, that's C. Okay. Okay, I'm getting into the tougher ones now. Oops. Oh, counting is my enemy. 6 standard 6-sided dice simultaneously calculates the product. Oh, okay. What's the product? What's the probability that the product is divisible by 4? Okay, I think I can do this one. I'm going to use complementary counting. So I just need to look at when the product is odd or divisible by 2 but not 4. Okay, so that's a good thing I have 20 pages here because I'm going to need lots and lots of space for these problems. Okay. Okay, so the probability of getting odd is, well, there are 3 odds at each turn, so that's, there's a probability of 1/2 each time, so it's 1/2 to the 6th. Yeah, okay. I always second guess myself, even when I shouldn't during these things. Okay, and then, okay, probability, oop, I keep hitting the wrong button. Probability, so that it's only even and not divisible by 4. Okay, so, I have to take a 2 or a 6. I can't use a 4, obviously, from the dice. So, and I have to pick which die is a 2 or a 6. So I have 5 odds, and then 1, 2, or 6. Okay, that looks weird, but one die that's a 2 or a 6. Okay, so the probability of getting... Okay, so there are 6 choices for which die is even, and then 2 choices for which even number it is, 2 or 6, and then well, okay, a 1/3 probability that it's even, and then the rest are odds, so that's 1/2 to the 5th. Okay, so this is 1/64. I think that's right. 1/3 times 1/2 to the 5th. Yeah, times 6. Okay. So that's 2 times, that's 1/2 to the 4th, so that's 1/16. Oh, stop. Okay, I think that's right. Let me just think this through for a second. Yeah. Okay, so 1/16 plus 1/64 is 5/64. So when I subtract, I should get 59/64. Let's see if that's an option. Yes, it is. Okay. This feels significantly easier than the 12A to me. Maybe that's just me, but I guess we'll see how I actually do. Okay, f of n is the quotient obtained when the sum of all divisors of n is divided by n. Oh, okay. I just need to do these, do the prime factorizations and see what I get. Okay. Okay. Well, this is really easy if you know number theory. Okay, so if I take, so sigma is the letter usually used for the sum of the divisors. So if I take the prime factorization and I find the sum of the divisors, it ends up being just 1 plus p1 up to p1 to the alpha 1, and I keep going into 1 plus pk plus pk. Oops, that looks bad. Pk to the alpha k. Okay, and then I can rewrite that using a geometric series. So it's p1 to the alpha 1 plus 1 minus 1 over p1 minus 1, and then I do that up to pk. Okay, so I just have to factor 7, 6, 8, and 3, 8, 4. Oh, 7, 6, 8 is twice 3, 8, 4. Okay, that's convenient. And 3, 8, 4, well, that's 4 times... Okay, 380 is 4 times 95, so 4 times 96. So I get 8 times 48. Okay, so that's 16 times 3, so 2 to the 7th times 3, 128 times 3, yeah. And then 768 is 2 to the 8th times 3. Okay, now I just plug stuff in, I guess. And I think that's all there is to it. Okay. Yeah, so I'm first going to find the sum of the divisors. So 768 will give me, okay, 2 to the 9th minus 1 over 1 times 3 squared minus 1 over 2. So that's 4 times 2 to the 9th minus 1. Okay. Yeah. Oops. I just want to be extra sure that... Yeah, okay. And then sigma of 384 is the same thing, but with the power lowered by, power of 2 lowered by 1. So, my handwriting is much better on paper. Okay, so that's 4 times 2 to the 8th minus 1. Okay, so altogether, we divide by n, and we subtract. Okay, so 768, we have 4 times 2 to the 9th minus 1 over 768, which was 3 times 2 to the 8th, yeah. 3 times 2 to the 8th minus 4 times 2 to the 8th minus 1 over 3 times 2 to the 7th. Okay. And let's see what that ends up being. So I can multiply the second fraction by 2 over 2, so that becomes 8 times, well, I'll just erase. Go away. Thank you. So it's 8, and then a 2 to the 8th. Okay, so it's 4 times 2 to the 9th, so that's 2 to the 11th, minus 8 times 2 to the 8th, and that, okay, those go away. So I have minus 4 plus 8, so I have 4 over 3 times 2 to the 8th, which is 1 over 3 times 2 to the 6th, and 2 to the 6th is 64, so that's 1 over 192. Okay, hope that's an option. Yes, it's option B. Okay. 13. Oh, this is right up my alley because I can do these trig identities. Okay, so I got basically a primitive 11th root of unity, and I just want to compare these two things. Okay, so and I know that a little fact that might help here is that sine 2 pi over 11, sine 4 pi over 11, all the way up to sine 10 pi over 11 is root 11 over 32, 2 to the 5th, I think. You take the odd number, subtract 1, and divide by 2, something like that. Yeah, there are 5 terms, so it's over 2 to the 5th. Okay, okay, so 2 pi over 11, so this bottom thing is, well, exactly this product. And then what's the numerator? Okay, well, I've got, I guess I'll start canceling. So sine 6c, so sine, remember sine theta is sine pi minus theta, so sine 6c equals sine 5c. Sine 9c is sine 2c by the same reasoning. Okay, this is really just, I don't even need any of this. That's way too complicated. Okay, sine 15c is sine 30 pi over 11, which is minus sine 8 pi over 11. So sine 15c is minus sine 4c, and then sine 12c is minus sine c. Is that really all there is to it? So I get 1. Okay. Maybe this contest is just made for me. But this, I usually have more trouble than this. Okay, P, Q, and R are polynomials with their coefficients. They have degrees 2, 3, and 6. And I want the minimum number of possible solutions to PQ equals R. Okay, so that equation will have degree 6, and I basically want to maximize the repeated roots. And I know that P of 0, Q of 0 equals R of 0 because those are the constant terms. So P of 0, Q of 0 equals R of 0. Okay, so that's a bad R. Let me redo that. Okay. What do I do now? Well, can I have 0 be more, be a common root more than that? No, I didn't phrase that well. Yeah, so, okay, I think I'm going to have to move on to a new page because this is, I can't do this in my head. Have I made any stupid mistakes yet, aside from maybe on problem 5? If so, please tell me. Don't tell me what the mistake is, but I'd like to know if I make one, because I'm probably bound to make one at some point. Okay. Let's see. I guess I'll just write out what. Oh. So once I pick P and Q, I can make R almost whatever I want. Okay, so if P is something like AX squared plus BX plus 1, and one sec, is it lagging? It's a little laggy. Okay, and then Q has degree 3 and constant term 2, so CX squared, or CX cubed rather. Oh, it's freaking out. CX cubed plus DX squared. This is really slow. What's going on? Plus DX squared plus EX. Whoa, I don't know what's happening. Plus EX plus oh wait, constant terms 1, 2, and 3. I don't know what I was thinking. I was thinking 1, 2, 3, and 6 or something. Okay, no, that won't work. No, that's not true. Okay, plus EX plus 1, or no, not 1. Plus 2 equals something x to the 6th plus blah 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 plus 3. I don't know why this is going crazy. Let's see. Yeah, I don't know what to do for that problem. Okay, let's skip that one. Plus it doesn't help that my cursor is freaking out. 3 identical, geometry. 3 identical square sheets of paper, each with, I think, 6 or stuff on top of each other. Oh. Okay. Okay. I'm just going to copy and paste the answer choices and the diagram. Okay. And the side lengths were 6? What was it? Yeah, side length 6. Okay. So this height here is 6. Okay. Well, all these side lengths should be equal. Because I've got this symmetry, 30, 60, 90, and so on. So I just have to find the area of one of these triangles and then multiply by 24. Okay, so I get something, well, that's really bad, but I hope you get the idea. Wait, are they the same? Yeah, they should all be. Okay, so This angle here is 15 degrees. Since it's one... Oh, wait, no. There are 12 of these pieces. Yeah. So it should be actually 30 degrees. Okay. I don't know why this is so... I might have to open a new page or something because it's freaking out. Okay, 30 degrees, and then this is 90, so that's 120, and that leaves 120 for each of the remaining sides. Okay, so I've got... Oh, come on. Okay, so... Got 90... How should I split this? Oh, well, I guess I first need some of the side lengths. So... well, this length here is half the diagonal of the square. So that's half of 6 root 2, so that's 3 root 2. Okay. So I've got these nasty triangles. So this is 45. I'm splitting it in half. And then I'm going to multiply this area by 24. 45, 120, and then, let's see, how much time? I have about 25 minutes left. Okay, 120, then this is 15, and this side is 3 root 2. Okay, so I guess I'll use a lot of signs. I mean, that's probably overkill, but, so, I really want these two, or I guess it doesn't matter. I'll pick this side here, and then I'll find the area that way. Okay, so sine 120 degrees over 3 root 2 equals... Oh shoot! I need sine of 15 degrees. Ugh. Let's see. Or no, I could do this side. I could call this x, so that would be x here. Okay, so sine 45 over x, so that's root 2 over 2 over x. So x sine 120 is root 3 over 2. And then I'm cross multiplying, equals 3. So I get x is 2 root 3. Okay, so then I need... Is this really going to work out to be an integer? Wait, what was it? Oh, no. It is not. Okay. Let's see. Oh, wait. Yeah, I have about 20 minutes. Okay. Okay, so now it's 1/2. The product of these two lengths, so that's 3 root 2 times 2 root 3, which is 6 root 6, times the sine of 15 degrees, and then I really want 24 of those, so I want 24A, well, no, I'll just write, times 24. Okay, so now I've got 3 root 6, I've got 24, so that's 72 root 6 times sine 15. Oh, I don't want to do that in my head. Sine 45 minus sine 30, sine 45 cos 30, root 6 over... Yeah, it should be root 6 minus root 2 over 4. And that way the root 6's will give me something nice. Okay, so then the 72 cancels with the 4 to give me an 18. So I get 18 times 6 minus 18 root 2. Ooh, that's really bad. Okay, 18 times 6, I don't want to mess this up, that's 108. So it's 108 minus 18 root 2. So 108 plus 18 is 126, 128. Is that an option? Please? Oh no. Okay, I'm gonna have to abandon that. Maybe it's time I start looking for problems I know how to do. I'm usually good at number theory, but this one looks like a lot of casework. Oh, hi, Punxsutawney Phil, again. Thank you for showing up again. I'm kind of floundering a little bit. Book starts at a vertex of a grid made up of equilateral triangles. That looks like a recursion to me. I don't know if I want to do that. U0, okay, I can usually do sequences. Okay, yeah, I'm pretty confident about this one. Ooh, this involves limits. Okay, nice. Okay, so let me go down. I guess I'm not doing that much worse than I did last time. The first several seemed almost too easy, and now I'm having a bit of trouble. I still have problems with number 5. I don't know if I want to go back to that. I think I might rather go through problems that, new problems rather than trying to figure out what's wrong with my old ones. Okay, so first of all, if the limit is L, then I replace all the UK's in the recursion with L, so I get L as 2L minus 2L squared. So I get, L minus 2L squared is 0, so L should be a half, I think. Yeah, 1 minus 2L is 0. L is a half. Well, or L equals 0, but I don't think that'll happen. Because, okay, the first U0 is a quarter. I'm going to start listing out terms. A quarter, and then 2 times a quarter, that's a half, minus 2 times a quarter squared, that's an eighth. So that's 3/8. And then I could make it a substitution. Oh, sure, why not? Okay, I'll make a substitution for UK minus L. So I'll say UK equals 1/2 plus AK. And I'm going to plug that in, and then my goal is to find out, this thing here is, stop. Oh, come on, cooperate, please. UK minus L is absolute value of AK. And I want to know when that's at most 1 over 2 to the 1,000th. Okay, so UK is 1/2 plus AK. So what does that give me in the recursion? I get 1/2 plus AK plus 1 equals 2 times a half plus AK. And then minus 2 times a half plus AK squared. Okay, now if I've done this right, I have a half here, 1 here, and a half here, so those all go away. So I get AK plus 1 equals 2AK minus Yeah, okay. AK plus a half squared is, I'll get a quarter plus AK. So that's a minus, a quarter plus AK plus AK squared. So when I multiply that by 2, I get the half from before, minus 2AK, minus 2AK squared. Okay. So first the difference is a quarter, and then, wait a second. Did I do that right? 1/2. Wait a second. Okay, gotta stay calm. I don't have much time left, but I don't think these could be alternating in sign. Okay, let me just compute the next one. So it's 3/4 minus 2 times 9/64. So it's 3/4 minus 9/32. So that's 8 times 3, which is 24. 15 over... Am I doing this right? 15/32? Or wait, no. Wait. 3/4 is 24/32. Yeah, 15/32. What did I do wrong? Oh, wait, so then the difference is 1/32. So the difference is a quarter, then an eighth, then 1/32. Okay, so those should be the AKs. Well, minus that. Oh, yeah. Okay. They don't alternate in sign because AK is negative. Doi. Okay, so the first was that? Yeah, that was U0. So A0 is minus a quarter. Okay, I'm gonna get rid of these annoying minus signs because they're just causing me more trouble than they're worth. Okay, so 1/2 squared. I'm just gonna write these out and see what the pattern is. So I start with 1/2 squared. 2 times 1/2 to the 4th, which is 1/2 cubed. That matches what I had before. And then I square that, that's 2 to the 6th, and then I multiply by 2, 1/2 to the 5th. I square that and subtract 1 from the denominator, 1/2 to the 9th, then 1/2 to the 17th. Okay, so the exponents are 2, 3, 5, 9, 17. So each time I multiply by 2 and subtract 1, multiply by 2, subtract 1. Yeah, okay. So they should be related to powers of 2. Oh yeah, they're one more than doi. Okay, I think I got it. So AK is 1/2 to the 1 plus 2 to the k. So like with k equals 1, I get 1/2 to the 1 plus 1. Okay. And I want 1 plus 2 to the k to be at least 1,000, so k is 10. Okay. I actually could have predicted that just from... if I'd looked at the answers earlier, I could have seen that the errors were shrinking really quickly. Okay, regular polygons. No, thank you. No, thank you. Okay, this I can handle complex numbers. So P of X is this wacky thing. Oh, okay. Is it really this simple? Okay, cosine x plus I sine x is e to the ix. Okay, so this is 1 plus e to the ix minus e to the 2ix plus e to the 3ix. Okay. Equals, how does that factor? Okay, so I'll write z for e to the ix, so it's 1 plus z minus z squared plus z cubed, so it's z plus, oh wait, does this factor nicely? Yeah, z plus 1 is a, wait, what am I doing wrong here? Oh wait, no. Minus 1 is not a factor. Okay, so I guess how many roots does this have? I basically just need to find how many roots this has on the unit circle. Well, so let me call that q of z. So, q of z, let me see, q of z, well, q of 0 is 1. It's got, I just have to figure out how many real roots this thing has. I know I'm not supposed to use calculus, but it is tempting. Well, and I want roots on the unit circle, not just complex. So I'm not totally sure what to do here. Okay, so if it had a root on the unit circle, then it would okay, if it had a root on the unit circle, then its conjugate would also be a root. And the product of those two things is 1. So it would have to, the factorization would have to look like z squared plus something z plus 1. The product of the two things would have to be plus 1. Then I'd have to have a z plus 1. But minus 1 is not a root. I just want to be extra sure that that's correct. Yeah. So it has no roots on the unit circle. Okay, so I guess the answer is 0. Okay. I guess I only have a few minutes left. So why don't I go back to problem 5? Oh wait, did I? Oh yeah, I messed that one up too, dang it. Okay, oof. Yeah, the early ones were a breeze, but then the later ones were tough. Okay, problem 5. Now I just gotta track that down. Now comes the tense part where I'm rushing to figure out what I did wrong. Okay, so come on, scroll, 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 please. Oh, this doesn't want to cooperate. Oh. Is it? Oh, here we go. That was weird. Okay, scroll, 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 scroll. Okay, what did I do wrong here? Okay. Now, so I did this GCD substitution And then I want the distinct... Okay, so these are all the possible... yeah. Okay, so these are all the possible values of D, and I want to know which ones give distinct values. Wait, but that's the same as counting divisors. I am confused. And for some reason I can't open the other file now. Okay. Huh. I don't know. Yeah, so like if 30 over D, so D is 1, so A and B are relatively prime. I get 1, 1. Yeah, that works. 1, 2, 3, 4, 5, 6, 8, 9, 10, 15, 16, 18, 20, 30. What were the options? Oh, finally, it lets me pick, or it lets me, switch tabs. Okay, so I had, wait, if A and B are both the 30th, then something goes wrong. Oh, okay, A and B are positive integers. Okay, so, something is weird here because, if I try to get the integer 1, then that means I'm getting a negative. So that's D equals 30. So A and B are both 30. So then I have 15 times 1 over 15 minus 2. Okay, let me go back. What were the conditions on X and Y? If X and Y... Oh! X and Y are at most 15! Dang it. Okay. So... Okay, I'm gonna cross off... And these are the values of D. Oh boy. Okay, okay, get rid of those. Okay, so... Can I get 15? Can I get all those? Got just enough time to figure this out. Okay, is it worth guessing? That would be 10 numbers. Okay, so I know it's 9 or 10. Wait, but that... D... Oh, no, it's the small numbers I have to cross off, not the big ones. Okay. I'm not sure I can figure this out in time. But, okay, I can't have 1 minus 2. Or 2 minus 2. But I can have 3 minus 2. So 15 times 1 over x plus 1 over y is 3. So 1 over x plus 1 over y is a fifth. Yeah. I think that's the list. Okay, 3, 4, 5, 6, 8. 3, 4, 5, 6, 8. That's 5 numbers. It's 12 numbers. Okay, 12. Can I get 30? 15? Yeah. Can I get 20? 1 plus a third? Yeah. 18 is 1 plus. 18 fifteenths is 1 plus. 1 plus. Yeah. Okay. I'm gonna trust that everything there actually works, and I'm gonna go with 12. Okay. I think that's right about time. Okay. So, let's see how I did. Okay. Okay, I'm gonna go to the solution page and see what we got. Okay, the moment of truth. This always makes me nervous. I mean, I guess it doesn't really matter, but okay. E, B, C. Is that what I got? E, yes. B, C, good. And then E, C, C. E. Oh no, it was. Oh shoot. Too bad. I'm gonna mark that in, I guess, yellow. Okay. Okay, D, D, B. D, D, B, yes. Okay. Please be CCB for 10 through 12. ECB. Oh. Why is that one 380? I'll have to go back and look at that one. Okay. What number was that? 10, 11, 12. What others did I do? I did 13. That should be E. Yes. I don't know that one. Don't know that. What was 15? 147. Okay. I wasn't that close. 16. Which others did I do? Not many. Oh, 18 is A. Yes. And 21 is A. Yes. Okay, I think that's all I got. Okay. So, let's see what I did correctly. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oof. That's not too hot for me. Okay, so 13 that I got right, and then 2 that I got wrong, and then that leaves 10. Okay, so that's 78. That's 93. Yikes. Okay, let me see if I can figure out what went wrong here. I don't know what went wrong with problem 5, but I want to go back to the problem 10. Oops. So that was the isosceles triangle. Where's my cursor? Come back. Where'd you go? Okay. Yeah, 10 was E. Yeah, okay. 40, 62. Yeah, okay. Now where is this thing? I gotta track it down. I'm gonna zoom out so that I can see it more easily. Oh, I think it was right here. Okay, so I have 20, 80, 230. Oh! I forgot the triangle right in the middle! Oh. Yeah, so it looks... Here's 60, here's 40. I forgot that this could be the base and these two be the sides. And then this will be at 50. Ah! Okay, so that would give me 380. Dang it! Okay, so I could have gotten closer to 100. For the 12A, I think I got about 110. So this wasn't too hot. But the first several seemed fairly easy, and then the last one's really... Well, I skipped through a lot and made some mistakes. But, yeah, like this trig one, the signs, number 13... That seemed really simple. Anyway, so I hope you enjoyed that. I apologize for not doing as well as I'd hoped. But I'm not a high schooler anyway, so it doesn't count for anything. And I do plan on doing more videos like this, more live streams. Probably, maybe with past AMC tests, and maybe with even AME tests if people really have the stamina for those. And I'd like to stream the AME this February when those become available. But I will, until then, I'll probably just do past tests. So thanks again for coming, and I hope to see you soon. Bye! Oh, and I hope to do better. Bye!